Okay, so we're going to skip part 1 of the warm-up because this requires a protractor, but I'll briefly explain to you guys what it's asking you to do or what it's trying to point out to you, okay? So it says each of these polygons is a scale copy of the others. So when I look at these polygons, it said name 2 corresponding angles and what could you say about the sizes of them? So what I'm going to do is I'm going to trace these angles for you. So I'm going to trace, and let me erase that so it could be a little bit neater. There we go. So I'm tracing this side of one angle. And this is angle ADC, or you could have put angle CDA. It doesn't matter, just as long as the D is in the middle. That represents the vertex. But basically what this problem wanted to point out to you is that even though the scale copies are all different sizes, the angle is still the same. Okay? So let me show that to you guys again. This is angle CDA or angle ADC. And when I hover it over its scale copies, it's still the same angle. And so what I mean by the same angle, which I'm going to try to draw that again. Let me hover it over there. So what I mean by that, this is the angle right here. And let's do that again. Because I don't want you guys to think it's the length of the legs. It's the actual angle itself that's in the inside. So if you notice, it's the same angle measurements. Okay. So then for part 2, it wanted us to check the actual angle or find the actual angle measurements. But we don't have a protractor. And I'm not going to force you guys to do that. But anytime that you have a scale copy of a figure and you want to check the angle measurements inside or the degree measurements, it's all going to be the same if it's a correct scale copy of a figure. So now let's move on to part 2 of this activity. Okay, so it says each of these polygons, and we already read that, so let's jump to number 1. So it says the lengths of these polygons are hard to tell from the grid, but there are other corresponding distances that are easier to compare. Identify the distances in the other 2 polygons that correspond to DB and AC and record them in the table. Okay, so let's look at this. All right. So I see DB, which is 4, and I'm going to use blue again. So DB is 1, 2, 3, 4. And remember that word when it says corresponds, it wants you to find something similar or a distance that corresponds with BC, which is going to be HL. So that's 1, 2, 3, 4, 5, 6. So, well, not HL, but HF is 6. Then for polygon IJKL, it's going to be L to J. So it's going to be LJ is equal to 2. Now for AC, which AC is right here, and I'm going to do that in red. AC is 1, 2, 3, 4, 5, 6. So that's AC. And G to E is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so GE is equal to 9. And then KL Oh no, is that K to I? I'm sorry about that. So KI is 1, 2, 3. So KI is 3. Okay, so the next question is asking us, look at those values in the table. What do you notice? Pause here so your teacher can review your work. So I want you guys to look at this table and pause the video and try to guess, what do you notice about this table? So the first thing that I notice about this table is that when I write the ratios down, say for instance if I do 4 to 6, 6 to 9, 2 to 3. If I simplify these ratios, which I simplify them, 2 to 3, which would be, I'm going to just do 4 over 6. Would be 2 over 3. 6 over 9 would be 2 over 3 as well. And this would be 2 over 3. And it says the larger figure is a scale copy of the smaller figure. So if you notice that all of them reduce down to the same ratio, which means that they have the same scale factor. Anytime an object or a figure or a polygon has the same scale factor, or it reduces down to the same ratio, that means that it is a correct scale copy.